Let me bring the headphone, please. Hello. Hello.
Yes, sir.
Yes, sir.
Now it is audible.
Sir.
Okay.
Thank you. Thank you.
Dear participant, moving towards the 13th lecture of this 5 days of FDP, I would like to heartily welcome Professor Bijan Sarkar, sir, to preside the session. Professor Bijan Sarkar, sir, he is now working as Professor, Department of Production Engineering at Jadavpur University. He is associate with this teaching and research field since from 1985. During his long journey in this novel field, he acquires expertise in different fields like tribology, reliability, technology, operation management, operation research, project management, soft computing, management development program. He loved to teach different subjects in the area of mechanical engineering, subjects like operation management, project management, maintenance engineering, and many more. His area of research, he has now handling different projects, and his area of research in project and operation management, reliability analysis, engineering, then productivity management, soft computing application in as his served from since from 1985. So it is difficult in our part to read all the area of his expertise. He has published more than 145 research paper in different pre-review journal of repute and presented more than 20 papers in different international conference. He is awarded by different organizations for his outstanding research like Tribology Society of India, Emerald Literati, New York, UK, Institute of Engineers, Indian Institute of Industrial Engineering, and many more. He has produced about 30 PhD scholar and more than 100 MTech scholar. He is member of different law society like Indian Institute of the Institute of Engineers, Indian Society of Technical Education, ISTE, Operational Research Society of India, Society of Reliability Engineering. Now I welcome Professor Bijan Sarkar sir to deliver the talk. Today his topic is Genesis of Manufacturing System. Sir, kindly grace the occasion and preside the session.
Thank you, Professor Chittaranjan Dev and Professor Santosh Kumar Sao for giving me this opportunity to share with you the wonderful, faculty development program. I am very glad. You are all young, dynamic professors, and you are all doing a great job for India, not only Sambalpur University, but for all Indian faculty members, Indian college communities. So this is my heartfelt thanks to all of you, and particularly the organizing committee for giving me this opportunity. So with these viewers, So we can go directly to the subject matter. The title is Genesis of the Manufacturing System. During my presentation, Ramesh Kumar, Sarada Farida, and Mohit Kumar, and Ramesh Tirthraj, and Gaurav Shukla, all are requested to interact. Basically, it should be not the monologue discussion, it will be the interactive session. I shall appreciate very much if you raise certain questions during the deliberation. Most important is that this is a journey. This is a journey, not a destination. So we are traveling by a boat in the Mahanadi River. So during this journey, 90 minutes, we have many questions, answers. Questions are important, answers are not important. We do not know many answers, but questions are important. So I appreciate if you raise certain questions regarding the subject matter. So with these few words, I am bringing my topic, sharing it with you. Just a minute, please. Dear participants, hello.
Yes, sir.
Am I audible?
Sir, clearly.
Okay, you are feeling comfortable, na? I am
Sir.
audible and also feeling comfortable. Hello.
Sir.
Yes, sir.
Okay, fine. So you ask me the questions. I shall try to give you an answer because genesis of manufacturing systems is a great subject. During this journey of 90 minutes, it's very difficult to complete on all aspects. But still, but I have tried to give the glimpses of this journey because what has been stated, the human society from the very old age, from the very ancient time to the modern times, so thousands and thousands of years passed, and thousands of gallons of water passed through the Mahanadi, Godavari, Krishna, Kaveri into the Bay of Bengal. But still, a lot of water has to flow through the rivers to the Bay of Bengal. But still, we are very much interested to know further how can we do better. So, keeping in view this idea, we are starting the journey of the genesis of manufacturing system. Now, a journey of 1,000 miles starts with a step, single step. So, this is very important. We shall have to travel 1,000 miles, but it starts with a very simple step. The content of the today's discussion, the evolution of revolutionary 5000 BC to 2020 AD, see all in the small, the omnipresent ideas. That is very important. This is very important item. See all in small. This is omnipresent. So during this journey, when we shall be studying or carrying out the research in production engineering or mechanical engineering, all the resources are with us. Only we need to have the clinical eyes. We all have the cortex eye, but we need to have the clinical eyes to see the everything present in around us. Then the Detroit decade 1893. So that was the beginning of the journey for the mass production system, Detroit in America. That car company, the first of its nature in the line manufacturing systems in the world. Then 1931, we have come to SQC and computer manufacturing 1960. Now, computer manufacturing is a very important topic during 1960, then 70, then 80, and now we have come to 2021. So how the computer helps even today as on date. Then 1990, we had the mass customization, we had the mass production, but there has been a paradigm shift from mass production to mass customization. Then in 2020, we have the inclined manufacturing system. There is a debate. There's a debate. What is meant by the word intelligent? Very simple. We know the manufacturing system, fine. With that we know from the first year BTech course, we know. But what is intelligent manufacturing system? Very simple answer to this question is that doing ordinary work in an extraordinary way is intelligent manufacturing. Gives rise to what is known as the intelligent manufacturing system. I repeat once again, doing ordinary work, we do not require very sophisticated equipment, sophisticated devices, but most ordinary things, but in a most extraordinary way. We can do it. So that is the intelligent manufacturing system, for which the cost is not very important. Then we have the Industry 4.0 Big Data Analytics 2020, nutrients 2014. Whatever we have got as on date and Industry 4.0 Big Data 2010, this is 2021, 22, we are going to 22, but nutrients, that's the most important, the forthcoming during the 20 years, next 20 years, 2040, we shall be very much interested with the nature, from the nature, study from the nature and how nature helps us to manufacture the product. The three important components in the nutrients is the holonic manufacturing system, bionic manufacturing system, and fractal manufacturing system. So fractal mathematics, bionic manufacturing system and holonic manufacturing system, they are coming in very big way in the next 20 years. So with this content, we go to the basic law of production. That basic law of production starts for the natural resource plus human energy times tools and techniques is the MMW. Ultimately, what we want, as I have seen the 83 participants are present in today's program. If I ask a very simple question, why did you join this program? Why did you join this program? So there is a question. The answer is must be there. So everybody wants something. Everybody wants something. So what is that everybody wants? You can ask any person at any point. What do you want, sir? What do you want? So any student you can ask, any research scholar you can ask, any principal, sir, even the chief minister, even the prime minister of India or abroad, you can ask a very simple question, sir, what do you want? This is very important. What do you want? And answer to this what do you want is very difficult. In one sentence, it is a one sentence question, but it is very difficult to answer the what do you want. So this program, the faculty development program, so we need to have to know something about the manufacturing systems, the domain of the manufacturing system, epistemology of manufacturing systems. So the output is the MMW, MMW, men's, material, and welfare. Ultimately, we all want welfare. Dear participants, ultimately we all want welfare. Like we have the 7 continents: Asia, Europe, Africa, North America, South America, Australia, Antarctica, and we have the 220 countries, and we have the 730 billion, 7.3 billion population, or 730 crores of population across the world. So everybody wants to be happy. Is there anybody in the class? I'm asking a simple question. Is there anybody in the class in the today's program? Anybody is who does not want to be happy? Anybody present in the class today, please? Yes or no? Do you want to be happy or not to be happy? Hello? Question clear?
Yes, sir.
Yes, sir.
So what is that? You want to be happy or do you want not to be happy? What do you want?
Sir, want to happy, sir.
Is it 105%, 10%, or 80%, or 100% true?
100%.
100%. So we all want, whether we are part of India, we are part of Bangladesh, we are part of Asia, we are part of America, we are part of Falkland or Finland, Japan to Geneva, Pakistan to Puri, Poland or Peru to Puri, Chile to Chilka, so Chin to Cochin, and Ranchi to Karachi, every part of the world, everyone wants to be happy. This is the general tenacity of human life and human mind. So everyone wants to be happy. Well, everyone wants the welfare, good roads, good accommodation, good clothing, good food, quality food, good treatment under this corona virus condition. So everything we want good, and good communication system also. So everybody wants to be happy. Question comes, how to be happy? That is the question. How to be happy? How to be happy and how to make others happy. Question clear? Hello?
Sir, sir.
Hello? Answer
Yes, sir. Yes, sir.
is not important. I repeat, we all want to be happy, but we don't. We all want to be happy, but how to be happy? That I am not asking. There are many ways out there how to be happy. So one of this part is this faculty development program. One of this is the faculty development program. We can attend this course, this program, and we can learn many things. We can apply those things in our professional life, in our teaching life, in our research life, so that we will be benefited. Everybody wants to be happy. So this statement expounded by Socrates. I think you all know Socrates, the great philosopher of Greece, 2,500 years ago, Socrates. So who doesn't want to be happy? This was the question raised by Socrates. Now, evolution of the revolutionary. You see in this diagram, one arrow is there, one bow is there. As we move further left side, the arrow will move very fast, very far long distance. As you understand from the physics, so more energy will be stored in the arrow, and it will travel many distance. So more distance means that history. If we learn history of this manufacturing system, that will enlighten us how to proceed further, how to go ahead. So that is why history of the revolutionary system, of the manufacturing system, is very, very important. This is a very simple diagram, but this diagram talks about we all must know the history, because whatever research you are carrying out, whether it is a CAD/CAM robotics, whether it is a planetary methods, whether it is a thermal engineering, whether it's a fluid engineering, now we all need to have history, the past research workers, what past research workers have done it. So we need to know all these things. So with this word, we switch over to the next slide. Genesis of the manufacturing technology. You see, there are 7 stages up there. One is the Stone Age, then the Pyramid Age, Medieval Age, Victorian Age, early 20s, late 20s, and early 21st century. Now you see, during the Stone Age, people are ready with the craft technology. The people had to survive. How to survive? By killing the animal. So they use the stone. So they make it pointed. So it came to the mind of the people during the ancient time that you make the pointed so that they know the physics of this craft technology. Because during that time they know the weight is the W and area is less, so more pressure will be there to kill the animal. So that is why the people started thinking from the Stone Age, and we developed what is known as the craft technology. Then we have the Pyramid Age, and during the Pyramid Age we have what is known as the project. As you understand, pyramid in the 3,000 years ago in Egypt, the people had to build the pyramid. See, at that time algebra was there, and also the area of the base, height of the perpendicular height of the pyramid, and so all the calculation made during that time. So people were aware of these mathematical calculations during that age. Number one. Number two, they understand the project, what will be the volume of the materials, from where the materials will be procured, how to procure the material handling devices, how to procure. That is what we talk about, the economic order quantity nowadays in the supply chain management and all these things. Now, during that time, during the pyramid age, the people started thinking how to procure the material from a long distance, And from there, they will bring the material. So, who will be responsible for bringing it? So, the scheduling, and also what the people involved in the construction of the pyramid. So, part and CPM during this 3,000 years ago, people were aware of the part and CPM, not in a sophisticated manner, but in a very no, but in a very ordinary manner. They know that who will be the person involved in the procurement of the material, who will the person handling of the material from a long distance. So the inventory control system, quality control system, and all these things were done during the pyramid age. Next comes the medieval age. This is the British time, 15th century. This is the 15th century, the process-based industry. Now, during that time, people, particularly in England and Europe, they used to use the woods for the fuel. Now, that when they cut the trees, so there's no more trees were there. So they started digging the soil to get the coal. So the process-based industry started in medieval age. Then Victorian age, we have the batch production system. We all know there's a three types of primarily discrete manufacturing system: line, batch, and the mass production system. But the batch production system came first. Then we have the line, and then we have the job shop production system. Now, early 20s, we have the line manufacturing system, the Detroit, that is 1893, and the Detroit in America. So people started and they are using the line manufacturing system. So the basic principle of the line manufacturing system, assembly line balancing problem. So what is the demand? What is the cycle time? That during that time, what is the cycle time, and what is the workstation process time? How many workstations will be there? And they find out the balance delay, and balance delay lower the better. So they try to find out this balance delay and also number of the workstation. So there are very mathematical tools are there that that you have studied in class in the BTech first year or second year, that are the largest candidate rule, or Pilbridge-Webster method, or the Moody and Young method, or ranked positional weighting method. These four are very popular methods which are used. So what we do it? So different algorithms are used to find out two things. One is the number of the workstation given the cycle time, or and also the balance delay. So as you all know that the cycle time lower the cycle time, so higher is the production rate. So they are indirectly related. So we try to minimize the cycle time so that delay will be reduced, and also our productivity will be increased during the early 20s, almost 120 years ago. Now, late 20s, there is in the 60, 70, we have the lean manufacturing system, waste minimization, how to minimize the waste. There are 7 wastes are there. One of the most important, the critical waste is the time, papers, labors. So those things, and also we are getting in touch with the environment. So the pollution plays a pivotal role. During the early 20s, no one thought about the ecological balance of the society. But late 20s, people are starting lean manufacturing system. So how to make the product so that it becomes the lean number one. It will be effectively used by the customers, and there will be no pollution of the society. And there will be the environmental pollution. Either it is a gaseous form, or it is a liquid form, or it is a sound. So whatever way, even the uranium, we know that Chernobyl in Russia, even in Japan, even also in India, 1984. I think you all know that carbide Bhopal gas tragedy. Bhopal gas tragedy. So people were not very much careful during that. Now people are getting alert. How to be very careful about this manufacturing process. And now early 21st century, now where we are we are talking about the agile, highly flexible, or the lean plus agile, agile manufacturing system, or we are going into what is known as Industry 4.0. Industry 4.0. Gradually, we are going to the Industry 4.0. So you see, our genesis is the origin. So it started with the Stone Age, craft technology. Now we are going to an age, digital era. So at any part of the world, we order through mobiles or through satellite communication. We need this particular product. So within 2 days or 3 days, the product will be delivered to the customer. And also, one thing is very important: the demand for this product is highly volatile, and also is longevity, WIP, work in progress, is also very short. So the lean manufacturing, the agile or agile or Industry 4.0, the digital manufacturing system, what we are discussing, we shall discuss very quickly, that we are doing through the digital system, digital manufacturing system. So that today there's a demand, volatile demand. Tomorrow there will be no volatile demand. Question is how to produce this product, because we need to have the very particular, the customer-oriented product, tailor-made product. We need to have the very specific material, and we need to have specific layout. We need to have specific machine tools also. So we need the specific machine tools. We need to have the specific material. We need to have the skilled operator who will be working on these things. So the thing is that people are getting excited and ignited how to develop these digital products without physically moving. So cyber physical manufacturing system. So this leads to a terminology that we should be coming later on: cyber physical manufacturing system. So we put an order through the cyber system, and we are getting the product. Suppose we are getting the product from, we are putting an order to Australia, and the demand is coming from South America. So within 2-3 days, the product will be delivered to the required customer across the world. So the now it is the digital manufacturing systems era, and many questions are coming how to address those issues that we shall be coming very gradually. One of the very important is big data analytics. How to apply the big data analytics? We can estimate the demand. We can find out the pattern of the demand. So which country, which demography of the world wants a very particular product, and what is the quantity, and when to be delivered, how to be delivered. So those questions, a lot of uncertainty are also present in this manufacturing domain. We shall come to slide where we shall see uncertainty management. Dear friends, one is the certainty and uncertainty. Certainty plus uncertainty is zero constant. If you have the more certainty, so uncertainty will be reduced. Like your potential energy plus kinetic energy is equal constant. Like your elevation head, velocity head, and elevation head, potential head, and pressure head is equal constant for the Bernoulli's equation. So if one head is increased, the other head will be decreased. Exactly the same way, if we make the system, if we make the environment clearly certain, so uncertainty will be reduced. So you can write down, my request, humble request to all of you, please write down this equation: certainty plus uncertainty is equal to constant. That means more certainty leads to less reduction of the uncertainty. Question comes. This is a challenging question for the production engineers, particularly mechanical engineers who are working on this product development, supply of the materials to the business customers. So how to minimize uncertainty, how to maximize certainty. So this is a challenging job. Now, through the application of the computer science and the statistical process, a lot of tools are coming up. One of the very important tool is the Dempster-Shafer theory, DS theory. Dempster was the teacher of the Shafer. He developed the model in 1967. Then they revised their model in 1967. That became, Dempster-Shafer theory. So uncertainty principle. So how to minimize the uncertainty, how to maximize the certainty. So that is a challenging job. in the 21st century. Now, in the Stone Age, you can see different stone materials are there. Some are the blunt and some are the pointed. People now another very important point which is coming up in this era of manufacturing system, the cognitive science. How to apply the cognitive science and mechanical engineering or the production engineering. What is cognitive science? Basically, how to respond, how to find out the responsiveness of the product, how to calculate responsiveness. Responsiveness, higher the better. Responsiveness. So how to get responsive very quickly. So now people are giving attention to this kind of question, how to make the system more responsive. So Stone Age, you can see. So the people are using a blunt stone, and some are, you can see, pointed. So pointed means the area is less, weight remains same, so pressure is high. It is easy to kill the animal, and they can survive during the Stone Age. Now, pyramid age, project scheduling and material handling. You see, during that time, people had to bring the material from a long distance. So that time, they know the mathematics. They know the mathematics. The area of the base, and the area of the art surface, and also they know the height, the perpendicular height of the. So Pythagoras theorem, 3,000 years ago, it was known to them. And metal handling, who only person responsible for material handling during that time. So this is a wonderful pyramid age, 3,000 years ago from today. But people started thinking. So that thinking is the most important. How to think? Everybody thinks. Question comes: where is the thinking capability in our brain or your mind? Thinking capability. Now, next 20 years, the research will be on this thinking capability of human mind in manufacturing systems. So nobody has, as on date, has worked on this particular area, human mind on the manufacturing system. But next decade, next 20 years, the researchers will be carrying out this kind of production by the mind management, along with the mind management. Then the medieval age, they are processing the mining ore from and they're processing this particular product. Then between the batch production, you can see the batches. The first is the batches. You can see the X mass there, even our different product shapes, they are being cut from a bar. This is the early line production system and Detroit. We have already discussed the three things are very much important. One is the cycle time is very important, and also balance delay, and also number of the workstations. So those three things are very important. And the four methods, very popular method, very simple but very popular methods are used. Largest candidate rule, ranked positional weighted method, Tilbury-Brewster methods are there, and also Moody and Young methods are there. And so given the cycle time, find out the workstation, or given the workstation, find out the cycle time, because cycle time is very much important related with the production rate. So people are interested to have more satisfaction in selling the product. So if they can reduce the cycle time, they will have the more production and they can earn more return on investment. The late 20s, we have the minimum waste and the zero defect, zero dust, and zero accident. So here in this time, we are talking about the TPM and TQM, total quality management. When we talk about the total quality management, we have the four components. The first component is inspection testing, then the quality control, then the quality assurance. The last one, the total quality management, where the customers have to be taken into consideration. Previously, customers' opinion was not considered, but gradually we are coming from the mass production to mass customization era. We shall see very quickly, and then we need to have both the lead time, production lead time, and the delivery lead time. So those are playing a very pivotal role in understanding that lean manufacturing system, zero defect, zero dust, zero accident, all these are coming. Now customers choice agile, or the lean agile, or the digital, whatever we call it. Now the thing is that customers is the king. Customer is the king in the LPG environment. Customer is the king in LPG. What is the LPG environment? Liberalization, privatization, and globalization. Customer can move from one place to another place, from one country to another country, from one continent to another continent. So customer is the king. So we have you all know that many companies in the world, they are buying the product from India because here the cost of production is much less in comparison to the developed countries like Japan, like UK or USA, like this. So India is getting more expansion, particularly in the UAE and Africa and other places, because they're delivering the product that you all know at a cheap cost as a minimum cost, so that it leads to what is known as the win-win situation. They are happy, and we are also, with the Indian industries are also happy. See, all in the small. So the DM, you can say DM change of mass. So whole manufacturing system is covered with this three equation 2, 3, 4. So the first equation, second equation talks about the change of mass is less than 0. Change of mass, third equation, change of mass is constant. Fourth one equation, change of mass greater than 0. So change of mass less than 0 is a metal cutting operation. All metal cutting, with the shaping, drilling, your lathe, turning operation. So all these are coming under milling. All these are coming under DM less than 0. DM equal 0, forming operation. All kind of forming, either cold forming or the hot forming, or extrusion process, deep drying. So there is no change of the mass, but the change of the orientation. Last one is the DM is greater than 1. The fabrication industry, DM, that is either welding, brazing, or soldering. Mass will be increased. So whole manufacturing scenario is covered by the very simple equation number 1. Decade, so we have the taxonomy of the production system. Already discussed production systems, discrete and the continuous, and the mass production, job shop, and the batch production system. So this production system, as you all know, that mass production system, volume production high, and job shop is the low. Variety of product low for the mass production system, like Maruti, like Ashok Leyland, the variety of product low, but the job shop is very high, like Gartner shipbuilders. So different, the MISL, Indian Space Research Organization, or Indian ISRO, Indian Research, or the DRDO. They are all different varieties of missiles are producing, but they're all varieties. So the variety is very high in job shop. The layout and product, hybrid and the process layout, machine SPM, special purpose machine to general purpose machine we use, and the labor is very skilled for the job shop and the low skill for the our mass production system. So graphical presentation and job shop to batch production system that we know in the first year class, BTech classes, but still this is very important to understand how we are moving from flexibility to productivity. Now, this SQC you all know, I have not discussed in detail because here we have Juran's quality management, and Phillips Crosby's the principles of quality management. So when you talk about the quality, so it is a conformance to the specification, and we need to have the things X bar R chart, P chart, C chart, and sampling, acceptance, single sampling, double sampling, triple sampling, all these things that we all know. So I'm not discussing this part. Competitive manufacturing. So and we use during 1960 CAD, CAM, robotic FMS, and automated storage and retrieval system. The 4 questions are there. What product does the customer want? I told you now that uncertainty. If you can estimate, so what product the customer want. Now we are moving gradually to from mass production to mass customization. So what product does the customer? Question comes: who will tell us? Market survey and demand and the culture of the society, demography. So these are all the sources by which we can find out what the product does the customer want, and how much. Second question: how much? If we know that particular product, like a car, how much of that product does the customer want? Very specific quantity. So demand analysis. So demand analysis, as you will study in the first year, second year BTech courses, There are various methods are there. But nowadays, with the help of the big data analytics and also multivariate analysis, we are going to find out very precisely and critically how much the customer want. Demand analysis. Now, when you talk about the genesis matrixing system, so we must also need to know that production, how much production demand is there. Unless we know, we cannot move forward. And third question, when does the customer want delivery? So today, tomorrow, after 1 week, after 1 month. So that is a challenging job, or instantaneously, like and the delivery, food panda. So they are giving. We are going to a hotel. We are going to a restaurant. We are placing the order. So within 1 hour, so our food is ready. Or minimum time. The question is that how to estimate that particular product. Now, I have not shown here another very important slide. You can write it down. What is known as the VAT analysis. VAT not the value added test. V and the structure of the product comes. V your number of the input will be less, but number of the output will be high. All food process industry, all food processes, all what we talk about that liquid that we talk about what we call is the drinks, hard drinks. Very low quantity component, but you will have the different volumes there. So the particular food industry, and so we get how much the V type, and the A type you have the more component, but output will be 1 or 2, like in the automobile industry, like missile, shipbuilding industry. We have thousands components, but one output or 2 output. US is and the V and the we have, and particularly in India nowadays, the food industry is becoming a very billions of dollars invested by the different companies in the food industry. Now, what they're doing, they're just making their input is the 2-3 items, and they're making thousands of products, different names, and they are making us the full, and we are the full. Really, we are full. We are saying this is new item, new thing. No, it is not new thing. Just changing the color, just changing the taste. So they are making the product sellable to us. So this is a B type, and T type is a assembly type of production, divergent and the convergent. And the fourth one is what does the customer want to do? I told you now. Suppose the customer is in South America, he wants the product from Australia. So how to come from Australia to deliver the product to South America? Similarly, even I have seen in UK, I have seen one from the food industry. I have seen in Birmingham. So the production food has been registered in Birmingham. So it has delivered to the what we talk about the Glasgow. So very quickly, 2-3 hours. So they have the cars and they are traveling. And even in Kolkata, Swiggy is there, Zomato is there, many agencies. Even if you look at another industry, service sector industry, which is coming a very great way, is Uber. So just they are applying this software, and they are scattering great network both in India and abroad. So people are thinking. 20 years ago, people could not think about the Uber services, Ola services. Now people are getting these services, getting the food services. So there's a demand. So most important is the dormant demand. If the practitioner can understand the demand, then only they can go for manufacturing the product accordingly. So estimation of the demand, quantity of the demand, and the delivery point. So these are the questions to be answered by the what is called the strategic planner, then only you can sustain, survive under this competitive environment. Now, customer value in terms of the demand requirement and supply issue. So, supply issue, demand requirement, we have the what is to be produced, how much to be produced, when to be delivered, and where to be delivered. So, these are the supply issue. Similarly, demand requirement, shape utility, time utility, place utility, so utility value. So, there is a very close mapping between the supply issue and the demand issue. Actually, this I already had discussed agility and the lean manufacturing system. Already have also discussed the difference between this lean manufacturing system and the agile manufacturing system. So, in the case of the lean manufacturing, it is a commodity. Agile is a fashionable use. Even in India, as on that, if you see pantaloons, I think even in Bhubaneswar, even in Puri, even in Delhi, even in Bangalore, even in Kolkata, there are many shops, outlets there for the fashion goods, particularly for pantaloons and other companies. So they are all making the product, and because the time is changes, taste is changes, so they are making the product, and the people are purchasing. People are purchasing this product. They are telling, "Oh, this is a beautiful, this is a new idea." Even if you look at the service sector, even the barber shop, even in Kolkata, we have seen if you visit one barber shop, the 400, 500 rupees they are taking, whereas in ordinary shop they will take 50 rupees, 60 rupees. So just 10 times they are getting this benefit of what is known as the digital manufacturing system, or digital manufacturing, or digital service systems. They are changing their pattern because the stakeholders or the persons or the strategic planners, they are changing their test. See, advertisement, another very important part is the advertisement. How much money they are spending for the advertisement? Crores of money they are spending in the advertisement to attract the young generation. Now, in India, particularly in Bengal, I have seen the people are rushing to that particular shop. But they're cutting their hair. But how much money they are spending? How much money? So this is the agility, different art dimension. And the market is volatile and predictable, and product variety is the low, and agility is high. I told you agility is the fashion their product. Either is it for the boys or the girls, and particularly if you see the boys and the girls for the 16 years to 36 years. So this is the age limit for the boys and the girls. Different product varieties they are bringing, and they're all like not only the not only your fashionable product, but also cosmetic product. They are all using this kind of product to have the greater market. Billions of rupees have been invested. Even health industry. If you look at the health industry, we are studying the people are using conventional food. They are not carbohydrate, fat, protein. They are going to smoothie. They are going to the smoothie. They are going for particular product, fat-free. They are coming fat-free, salt-free products. Now, crores of money invested. People are going to purchase. But you see, those are all befull us, because our traditional food, whatever carbohydrate, fat, protein we are getting for the last 30 years, 40 years, or 100 years, they are replacing. They are through the advertisement, they are changing, and they are forcing us. They are forcing to purchase that product. So there are various ways we can see that people are thinking, but we should be very careful to be very selective regarding the selection of the product. This is the matrix based on the market winners and the market qualities that I have already discussed. This is the difference between agility and the leanness. The market knowledge, root map for the integrating the leanness and agility. So, market knowledge, so demand analysis, demography. So, what is the culture of the society? So these are all they are taking care of. They are very meticulously finding out what the test, that changing the test, particularly young generation, they're changing that test, and they are the target group. And these multinational companies, their target group are this young generation, and lots of money, crores of money, they are getting from this young generation of India, and also young generation of the world. The link to FMEA, TPM, SWAM, POCAYO, and the Kaizen and 5S that you all know, say the second phase of HSC and routine. So these are very known by which we can minimize our risk and maximize our connectivity. The possible solution known to date for the above problem is competency with manufacturing. We relies on the principle of complete integration of all the islands of automation to encompass each and every activity to be provided under computer control. This is essentially marriage between information technology and communication. So the SIM is basically the marriage between the IT and the communication. Because different islands of automation from there. This should be connected, all should be connected. Now this is the digital era. Digital era, as you understand, we're all connected by the digital devices. So this is a plus point. But there's a minus point is that even I have seen, very recently I have seen the people from the hospital, they are telling, they are sending SMS for checking up your this coronavirus, all these things. Now, so there is the pros and there is a cons to each product. It includes the computer-aided design, computer-aided manufacturing, and planning and control, and other business data processing systems. One of the interesting attributes of SIM systems is its ability to execute dynamic scheduling the event of any changes that exigencies in the priority execution. This is another very important dynamic scheduling, not the static scheduling. So whenever there is a change in the demand, change in the layout, change in the material, so we must change ourselves. So change is the only constant. Now we know our expert system. Gradually we are moving into the higher dimension of manufacturing system. Expert system is the decision table, professional the predicate calculus in the product, and AI-based language developed in 1972. So decision table, this is the notation of the decision table. You can see the condition stuff and the rule of the condition C1, C2, Ck, and there's the rule R1, R2, the condition entry, the action stuff, and the action entry. So we can get, if we use the rules, because basically we shall be going to the rule-based system later on. Even if we go to fuzzy system, fuzzy neural network system, neurofuzzy system, we using this notation the decision table. So we have the predicate calculus, professional calculus. This is very interesting subject matter. Very interesting. This guys to what you know the AI, artificial, how machine can take decision. Computer can take decision based on the this are the input. So that will be the output. Basically, this is the input output analysis. By the way, whole domain of the production system is based on this input output analysis. What are the input? Input is the node, and output is the outer node. So only processing, output is the dependent variable. So output is a function of the input. How the thing is manufactured, so that is the challenge of the engineers. Now we use the different notations in the decision table and condition stuff, like what are the conditions, this and this and this, that we have to use in the Boolean operation also, Boolean operation. In the first year of second year electronics class, we have studied this if-then rule, basically if-then rule. So this if-then rule also applied in the fuzzy expert system of the neurofuzzy expert system. Gradually it will be coming, because this is the foundation. This is the foundation for the clip set, and then we shall be going to the fuzzy set. Some of the examples are there given. Some of the examples. If a material given Helmholtz number is 21 coded or above, the condition is 1, and if you say this 100 kpsi and more, then classify the material as type A, action A. So there are different rules of the rule-based expert system, and this rule also used in even in the fuzzy neural system. Now this is an example, very simple example. Now if you look at the next table, this condition can be written as VHL value condition 1 greater than or equal to 21, 10 is greater than 100, PSA, KPSA, VHL less than 1, and 10 is greater than 1. will happen? So we get classification. Classify material A. If it is yes or yes, the first rule. Second rule, because 2 to the 2, 4 combinations are there. So we get the metal B, metal C, metal D. So this is the one way of classification of the material. Also, we can also classify the customer similar way. Also classify the product. So this is a very simple but very powerful tool. Very powerful tool. We can apply this decision table even for the our decision making process. It's the same thing. 5 different methods of producing holes in the faster exit. 40 RC scale. Rockwell RC scale investigated. The process considered that electrochemical machining, electrical machining, chemical machining, electron beam machining, or laser beam machining. The hole size and the thickness were 1.05 millimeter and 1.94 respectively. Based on the concept of the figure next slide, we shall show that the components of the decision table is shown, and figure next slide has been obtained by considering the forward chain. This is your output, and these are the all input inference network for the method selection. So this is the very simple, but very powerful tool how to diagnose. So this is the beginning of predicate calculus, or what we talk about the AI, artificial intelligence. So this is a very simple but very powerful tool, and we can recognize the systems. This is another problem. Now, proportional calculus is the predicate calculus. The proposition we are entering gradually into the AI in manufacturing system. Now, basically, proportion is a true or false statement. Whether it's a functionality. Suppose it is raining or not. It is raining. True or false. So this is basically dichotomous state, true or false. So this way we can find out the different symbols are there. We have the 5 logical connectives are there. A conjunction, disjunction, implication, bidirection, and negation. So these are the things that we have studied. All of us have studied in our BTech courses, particularly in the logic classes, in the Boolean algebra classes. Boolean algebra. So you can consult any Boolean algebra book, or you can study even what we talk about the artificial intelligence in books, Patterson, Nelson, and Blatt-Kosko. So those are very beautiful books, very simple way they have treated this fuzzy system and the expert system and the proportional logic. Blatt-Kosko, Nelson, Patterson. So those are the very simple books, but those are very helpful for us to guide our students, even undergraduate students. We can guide our students to write down a rule-based expert system. Suppose this is a welding machine, welding process. So when you'll be using a electric arc welding or submerged arc welding, so what are the conditions are there? So we can give the assignments to our students also. With the measuring instrument, we can give the different type of measuring instrument. So when will be used what type of measurement? Whether it is a camera-based system, it is what we talk about Vernier scale. Very simple. Let's talk about Vernier scale. So what are the conditions that we can use, or the sign bar? So what are the conditions that there for this? I should be using the sign bar. I will be using the camera system for the ovality, for the circularity, for the perpendicularity, for checking, and what is the resolution of those things. Even the micrometer or vernier caliper. So these are very simple. And sophisticated equipment also you can use. You can also say our students sophisticated equipment. But to start with a very simple one, we can give the assignment to our students. You can write a expert system based on this. We can find out the conclusion. The first order logic. So what is the professional logic? As in the world content, the fact. Basically, facts and figures. I just said, is it training? Yes or no? All the students are attending the classes? Yes or no? All the students are present in the class? Yes or no? So yes or no. So dichotomous. But when it comes to the fuzzy system, we have the multivariate logic. The difference between the flip set and the fuzzy set is that in the case of the flip set, we have the either black and white color, or present or absent, 0 or 1, switch on or switch off. But when talking about the multi-threaded logic. Whether then we use what is known as the linguistic variable. We use the linguistic variable and also membership function that we shall come to gradually. And also you can give the assignment to our students also. Now Prolog, Prolog is a very almost 50 years old, still valid today as on date, programming logic. And the real world, so we try to expand the abstraction, knowledge representation, and the type of Prolog model. So expert abstraction, basically pattern recognition. Now in the computer science and also in computer science and statistical analysis and mechanical engineering. So now it is the era where a mechanical engineer cannot do alone. A computer scientist cannot do alone. A statistical analyst cannot do alone. We need to have the integration of the statistical analysis. We need to have the integration of computer science and also mechanical engineering. Then only under this competitive environment or a changing environment or what we talk about the digital manufacturing system, we can be able to produce the product, required product can deliver the product at the right time, the right quality to the customer. So this has come in a very big way, in an integrated way. Or you say that it is the automation connection in the island, automation on the island. We can have connecting. Now, this cyber physical manufacturing system, which I'll explain very quickly, cyber physical manufacturing system. We need to have this demand. Now, who will be producing? What is lead time, manufacturing lead time, where the availability of the product is there, available raw material is there. From whom should I get the raw material? Vendor analysis. That is another very challenging job for mechanical engineering. Vendor selection. In the supply chain management, a lot of uncertainty present. So from where we shall get the material, how to get it, what is the price, competitive price is there. So these are all much challenging things that we must do. So this knowledge acquisition model, Java Prolog language model, we need to have. So this is the procedural language that we all know, object-oriented language. This is the expert system, human expert, knowledge engineer, and the knowledge-based expert system. So here also, human expert will try to get the extraction of the knowledge engineer. So particularly pattern recognition. Even in big data analytics, our objective is to find out, so what is so much volume of the data, variety of the data, velocity of the data. So how to tackle those things and explore. So what is the pattern embedded in this big data analytics? So if we can recognize, we can identify the pattern, then it becomes easier for the manufacturers to produce the product, to deliver the product, and to get the competitive advantage in this highly competitive environment. So these are the things to get the competitive advantage for the product classification on the pattern recognition, So there are various tools and techniques are coming up. By which can recognize the product that we identified. This is the advantages in the expert system, and this is of the user. Now, mass customization, which I have already said, the LPG stands for the liberalization, privatization, and globalization. So the paradigm shift from mass production to mass customization. This already has this is a very important point. And a comparison of the design for customer and design by customer. Design for customers or design for mass production and design by customer is mass customization. So that is design for. So saying very quickly what is L by D ratio, and then production lead time by delivery lead time. Next slide. This the modern concept of manufacturing system. P by D ratio. You can see the one hand is the manufacturer, another hand the customer. Because we want a very particular product, whether it is the service sector, whether it is the manufacturing, hardly matter. Even if we look at the different hospitals which are coming up in a big way, particularly in Kolkata and also in India, service sector. So manufacturers, the certificate, customers, the patient, health industry. So previously it was the MTS make to stock, now it is ETO, engineer to stock. A particular product, like from India, from Kolkata, many patients are moving to Chennai for getting the better treatment and cardiac arrest for the rental problem, even for the eyes surgery, uh, brain surgery. So people are moving from Kolkata to Chennai, Hyderabad, even Bangalore. Uh, uh, so they're getting very specialized treatment there. Now, what they are doing, there is uh, uh, what is known as the ETO, near to order, patient to order, where P/D ratio, production lead time by daily lead time is less than 1. So that is a challenging job. And P/D ratio greater than 1, much greater than 1 is the make it square. So that was the mass production system, and ETO is the what is known as the mass customization. So from mass production to mass customization, we must be very careful what is the amount of the product, what product to be delivered, from where the product will be produced, what is the quantity, and when to be produced, what to be delivered. So those four questions have to be answered, and only then, if you can answer those things and prepare the product, then only you get the benefit of this production system. And this is the difference between this EQ and one is the speculation, is the commitment, focus and the impact, uncertainty and certainty. As I said, uncertainty and certainty is just constant. If you have the more certainty, uncertainty will be less. This is the same thing in a different way. This is the same thing. This is a customer order decoupling point or order point. This is the same thing in a different way. Factor affecting customer order decoupling point. So I have already said that the knowledge increases from uncertainty to certainty, and knowledge decreases from certainty to uncertainty. So certainty plus uncertainty is a constant. So risk is lying between, and then risk will be 0 when it is certain, risk will be 1 when it is uncertain. In the case of uncertainty, we do not have the probability there. Uncertainty principles, the Shannon theory, measure belonging, measure confusion, measure necessity, all these things. We have the FST fuzzy set theory, rough set theory, denser set theory, soft set. This is very important. This already I have discussed in my early period of discussion, that based on supporting evidential references, what we get evidence. So one is the supporting and another is the against. This is the same thing in a different way, P/D ratio. Now, this is a very simple slide that we all know. Data, information, knowledge, and wisdom. So data, raw material, to influence product. Knowledge, we have the two parts. One is the explicit knowledge and the tacit knowledge. This tacit knowledge are not taught anywhere in India or in abroad. Now the time has come during 2040, when we shall be going to the fractal manufacturing system, bionic manufacturing system, hologram manufacturing system, we must take into cognizance our mind management in manufacturing, and robotics, and FMS, and in digital manufacturing, cyber physical manufacturing system. We must take into cognizance mind also. Then we can. This already I have said of the intelligent manufacturing system. This already I have said unclearly as well. What is to produce, when to produce, how much to be produced. So this is the unscientific Q. Already discussed. This is also an example already discussed. This is abstraction and subtraction. We already have discussed. This is the information flow and the production flow from the supply end to the customer, and from the customer to the manufacturer. The key benefit from the intelligent system, already we have said that everybody wants to be happy. If I'm to right now in one word, so we want to be happy. So the HANA subjective for the 2020 generic system. Now, this is another very important slide. Stress analysis, political, economical, technical, and social. It was not discussed earlier. This was not considered earlier. Now, And the people are considering gradually political scenario, social system, because product pattern. Because I think you know, a different society uses the same person in different way, different way. So technical aspects, how to reduce the idle time or work in progress, and environmental protection and economic growth. So those are to be considered simultaneously. So human intelligence, we already said that human mind. Already we have said artificial intelligence, developed artificial intelligence we have said. Now intelligence system is persistent, subsystem, artificial neural network, genetic algorithm from intelligence system. So these are all very vast subject. 90 minutes duration is not possible to give on the glimpses. You can get the glimpses of the total total idea. But gradually, if you go into one subject area, then you can able to handle the solution. The fuzzy system, I already discussed about the fuzzy system. It's a Jabir is the electrical engineer, is from Iraq. In 65, he developed this. But when he developed this map, the people were very angry and they were going to kill Professor Jabir. But somehow that was possible to save himself from the backwards. So we have the this function and the concept for the number we are if you find number first page, number gain and problem and
Sir,
how to find the real
Vision, sir.
rows interval 0 and 1. So this is basically multi-value logic, multi-value logic. Because the HP, I have given an example. I'm not discussing this now because this is another very important area where you can use, you can give it to the student also. Because how to apply fuzzy HP system for selection of the FMS system. This is a very simple algorithm, but students will be interested to get the idea. Fuzzy expert system, the fuzzy expert system. We have the input classification inference engine. Hello.
Sir, is there any network issue?
Pardon?
Sir, is there any network issue?
Network? No. You are not audible.
Sir, no, sir. You are not audible.
No, I think. Let me check.
Yes, sir. Now it is audible. Now. Yes. Yes, sir. Audible, sir. Now, sir. It is okay, sir. Yes, sir. It is okay, sir.
Hello.
Yes, sir. Yes, sir. Yes, sir.
Now it's visible.
Yes, sir.
Okay. Just a minute. 58. 58. Hello.
Yes, sir.
Now it is audible.
Yes, sir.
Oh, okay. Thank you. Also visible also, right?
Yes, sir.
Okay. Now we are talking about this fuzzy system. Sorry. Professor Jave developed this model only around 50 years ago from today. It's a completely new one. Fuzzy 2 type is coming up in a big way. Fuzzy 2 type. This is a membership function. This is very simple. The only thing is that if we calculate, then we practice it, we discuss this, and then it becomes very easy for us, for our student also. We can give home assignment internship to our students also to carry out on the mechanical engineering problem using fuzzy set system. Fuzzy expert system, how to. So another very important inference engine and wheel-based. I have already discussed the decision table. There we have said something about the rule-based if-then rule. and we have the defuzzification, fuzzification to defuzzification. Ultimately, we get the. Hello, am I audible? Hello.
Yes, sir.
You are audible.
Yes, sir.
Sir.
A fuzzy express system. So express system we have studied. Now we have the input, the key value. We know for the fuzzification is there, and we have the fuzzy inference engine and also the knowledge base. Basically, the difference between knowledge base and your database is that in the case of database, it's a statement, proposition. Smoking is injurious to health. Knowledge base is if you smoke, you can susceptible to cough and cold or dangerous disease. So this is the difference between knowledge base and we get the defuzzification and ultimately we get the fixed output. And artificial neural network. So this is the not long back. It's around 40 years, 50 years ago. The neural network has come up. There's the input, there's the output. So the mathematical relationship is there. We have the hidden layer. We can find out what is the architecture, what is the learning algorithm. These are all very simple algorithms. We can teach our students also this artificial neural network. Biological neural network, how people can make decisions. Ultimately, people make the decision. In the case of this in the case of the genesis monitoring system, ultimately people are making decisions. What is to be produced, how much to be produced, when to be delivered, and how to be delivered. So those are the questions can be gained by the artificial neural network and also the big data analytics. So this is the introduction for the artificial neural network feed forward back propagations. Our mind, how does the mind works, or the brain works. Artificial neural network input layer, hidden layer, and the output layer. So ultimately, we try to find out the error, MSE, mean square error, minima, lower the better. We are getting a function, and we are getting the input, and what is the output. So our objective is to have the error from function should be lower the better, MSE. So that is the only simple tricks we can get it. Now MATLAB is there. The students can write their code in the MATLAB, because in the MATLAB this tool is available and it's very user friendly. In the case of the the MATLAB, it has become user friendly. Even student can themselves work on this neural network system, different neural network, and basically classification. And what we are talking about, the big data analytics, classification and regression tree. We use the artificial neural network in big data analytics. This is the model of the NFS, the fuzzy system to neural network system, and neural fuzzy systems. Not only the fuzzy system, but not only neural, but combined neural and the fuzzy system. So we have the CRISP input application database. We have the fuzzification module. Different methods are there. Many methods are there for the fuzzifications, depending on the membership function, and we use the fuzzy rule base. Already we have seen what is the decision table. The decision table, from where we can find out the rule base, and the neurofuzzy module. Ultimately, defuzzification we can the CRISP output. And there are various defuzzification methods are there. Very simple methods are CG methods. Yeah, very simple methods. Genetic algorithm. This is another very old method. I think in the background of this, the development of the genetic algorithm by Daniel Goleman. So he developed this method based on very simple arithmetic, evolutionary operation, EVOP. Evolutionary operation. We can use the EVOP. Even the design of experiment, we know the one-way classification, two-way classification, factorial design, Latin square, and we use the evolutionary algorithm from where we develop the genetic algorithm. This is the very simple flowchart for the genetic algorithm. This is a gene, chromosome, and the population, how they are interchanging among themselves to have a new fitness function. And then we have the particle form optimization. This is another very important area of research. It is also the ages of this particle around 30 years old, but still it finds application in our day-to-day life. so student can be given the assignment for when the maintenance engineering, reliability engineering, people can be given this problem. Now we are going to how to find out the bard. So this is the example recognition. I said the pattern recognition. How to find out the pattern. Now this was previously the robot and the laser system position. You can see no cyber system is there. We are gradually entering from the industrial 3 revolution to industrial 4 revolution. So it is I have already discussed that now the time has come for manufacturing science, data science, and information science. They all come together. Manufacturing scientists cannot do alone. Data science cannot do alone. Information science, computer science cannot do alone. So we need integration of the mechanical engineering, computer science, and also what is known as the statistical science. Industry 4.0, already I have said something about the Industry 4.0. The industry that was shifting Industry 1.0 when the water is being lifted, Industry 2.0 mass production system, then Industry 3.0 robotic system, Industry 4.0 cyber physical. Now here the no man is there, and they are getting to the physical system, cyber physical system, and the product is being produced and delivered to the customer. But there's the limitations. There is the limitations, and tell your student to find out the limitations of the Industry 4.0. With a smart industry and with big data for the development. Now we use the mass sensor, tactile sensor, non-tactile sensor, mobile phone sensor with the radio communication, and ultimately cloud manufacturing. The cloud manufacturing. The same thing in different way. The Internet of Things. This is another very important. We use the sensor with the radio communication with the processing of the storage. So these are the things. There is the Internet of Things that we must. IoT and the big data analytics, the cyber physical systems already we discussed. The physical world and the virtual world, we use the IoT in the virtual world, but in the case of the physical world, we use the CAD and robotics, all this. This is the cloud manufacturing. We are going to graduate to cloud manufacturing area. These are some of the research work what our students can be given the ideas. They can use the network analysis. And this is you can see the product. Either use the mobile phone or the web-based. The management background is there. They're producing the product and deliver it to the right-hand side. And you can see different products are there. Different products are there. So their materials are the same, but different products are there. So these are the big data analytics. So decision ultimately big data. So we use the analytics. You can see what is analytics. I can show. This is a very important slide. You can take this slide also. This slide you can take. This is a hindsight, inside, and the foresight. This is a descriptive analytics, diagnostic analytics, predictive analytics, and the prescriptive analytics. The prescriptive analytics is very optimization. A lot of optimization methods are used here. These are the pre-processing data, and we get the what is known as the machine learning. How the machine supervised learning and unsupervised learning. Here you use how to recognize there is a dog or a cat. So there are certain rules are there by which that we have already seen in our decision table and also in the neural network. So the difference between among the deep learning, machine learning, and the artificial intelligence. Now new trends already we have discussed in the previous slide. The bionic manufacturing system, practical manufacturing system, the holographic manufacturing system. So the next generation manufacturing 2040. So how the nature, how the bionic coming, the biology plus electronics, how a tree can repair its own worm or defects. So fractal, because of the fractal bundle amount is 1967. So he developed this fractal manufacturing system, and the holonic, because it is the holon. A lot of holons are being applied. So these are all in the what we talk about the research stages there. And gradually we shall be able to find out gradually move to from digital world to cell biology in the manufacturing systems. So these are some of the hierarchical model and structure, and the model and structure one is model and within the system or outside the system. So fractal already Mandelbrot is a lot of papers are there, lot of work already done in the field of manufacturing system. Even in the tribology, we have used the fractal mathematics in recognition of the type of wire, where there is we're talking about the adhesive wire, fretting wire. So just by seeing the photograph through the CCD camera, if we take the photograph and we can analyze to the fractal. So this is a very simple way of understanding this fractal diagram. This is a fractal manufacturing system. This is a fractal A, fractal B. We are getting the output. This is holonic system. This holon is coming from the proton or the neutron. The concept is the cooperative, collaborative, cooperation, collaboration, and association, and autonomy. This is very important for the holon manufacturing system. Here you can see the physical structure of the holon 1. So robot, CM, all are connected, and holon 2, where we have customers end. So they will interact.
Sir?
Yes, please.
Sir,
Hello?
we try to sir, conclude because sir,
Okay.
time is already, sir.
Now, with this, I think we are coming to the last point of our slide, holonic attributes. Basically, is the collaboration, coordination, autonomy, and the cooperation. So with this, ultimately, it's the productivity, effectiveness by efficiency, and miles to go before sleep. And the best way is to come. Let us be unstoppable. Stay hungry, stay foolish, stay sure. Thank you very much, and thank you all once again.
Any question from participants? Please put in chat box, or you may unmute or directly ask to our sir.
Santosh.
Sir. Okay, any question?
Question is important, answer is not important.
Okay, thank you. Okay, thank you, sir, for sharing your vast experience and expert in the last 25 years regarding this area in the field of genesis and manufacturing technology. We have learned so many things from that area. Especially in this lecture, we have to know what is the genesis of manufacturing technology, or then what is the evaluation, the revolution of these their project scheduling and material handling. Then like that, CAD, CAM, robotics, FMS, RMS, then export system, then proposition of logic, then fast order logic. Then we have also learned what is ProLearn, then manufacturing, then what is the modern manufacturing concept, then what is PA. So many things we have learned in that single slide. And sir already told that within that stipulated 90 minutes is not fulfilled about the genesis of manufacturing technology, but still sir is trying to cover all that area. And thank you again, and which are very interesting. And I hope all the participants got the knowledge about the different techniques and new innovation regarding the fields. Thank you, sir.
Thank you.
Sir, namaskar.
Sir, namaskar.
Thank you, sir. Thank you. See you, huh?
Sir.
You can leave now.
Yes, sir.
Thank you. Thank you. Thank you.
Okay, dear participants.